Let us start this lecture with a thought process from Abraham Lincoln, who says that towering genius disdains a beaten path, it seeks regions hitherto unexplored. Most of us follow the path which is safer, and that means it is taken by other people. But we can't really explore our capability unless otherwise we take risk in life. And with this thought process, let us now recall what we learned in the last lecture. We basically looked at what do we mean by propulsion, and then what are the laws of motion that govern the propulsive devices or the process of propulsion. And later on we also looked at according to the third law of motion, which is the basis of the producing thrust in a propulsive device. Some of you might have experienced, that is, every action is equal but opposite reaction. For example, like when you jump from a boat near the shore, then you will see that when you jump forward, that boat is moving backward. And some of you might have experience of the pain due to the impulse provided by the butt of the gun when you are firing it, and that you can experience. That is the example. Similar way, the rocket is being propelled due to the change of momentum of the high temperature gas through the nozzle, and as a result you will be getting a thrust. And later on we classify the kinds of the propulsive devices. We classified into two categories. One is air breathing engine, other is non-air breathing engines. And later on we also looked at various engines like piston engine, Wankel engine, turbojet engine, turboprop engine, turbofan engine, ramjet, scramjet. Then of course then we divide non-air breathing engine into three categories. One is photon, solar cell, and then rocket. Rocket we basically again divide into two categories. One is chemical rocket, other is non-chemical rockets. And we will be discussing more about basically chemical rocket engines, and of course we may touch upon the non-chemical rocket engine in this course. But question arises, what are the differences between air breathing and non-air breathing engine? That you might have studied earlier about the air breathing engines. So how it is different than the rocket engine or the non-air breathing? As the name indicates, that in case of rocket engine or the non-air breathing engine, both the fuel and oxidizer are being carried by the vehicle, which will be burnt in the combustion chamber for producing and expanded in a nozzle for producing thrust. So let us look at what are the differences. As I told earlier, air breathing engine uses atmospheric air for the combustion or producing high temperature gas and high temperature and pressure gas that will be expanded through the nozzle, whereas in the rocket engine it carries own oxidizer and fuel. As a result, this will be self-sufficient in traveling even beyond the Earth atmosphere. Hence it can operate in atmosphere and also in the space both, whereas the air breathing engine, it cannot operate in the space or the vacuum. It can only operate around the Earth atmosphere envelope. So, and the air breathing engine, it really breathes the air the way we do for our survival. Its performance is dependent on the altitude and the flight speed, whereas the rocket engine's performance does not depend on the altitude and flight speed. Therefore, it is really have a better control. And the thrust of this engine, of the rocket engine, is independent of flight speed. In other words, whereas for air breathing engine the thrust developed by the engine is dependent on the flight speed. And this air breathing engine or the like turbojet, turboprop or turbofan, even the piston engine cannot operate beyond the supersonic speed of Mach number 5, whereas the rocket engine can operate in any flight velocity starting from even 0 Mach number to the 25, and rate of climb of the vehicle decreases with altitude because of fact that the density of the air decreases along with the altitude in the earth atmosphere, and the rate of climb increases with altitude because the drag will be reduced for the same kind of thrust, it will be increasing when it moves certain altitude. And flight speed is always less than the jet velocity, that is the velocity, jet velocity through the nozzle, whereas the flight speed is not limited by jet velocity, that depends on basically the design with which it will be. So, therefore, if you look at, there are several distinct features by which one can separate the rocket engine or the non-air breathing engine from the air breathing engine. So, as I told earlier, the rocket engine is supposed to operate not only in the atmosphere of the earth, but beyond it and also in space. Therefore, it is very important to carry both the fuel and oxidizer. As a result, it is also the cumbersome and the payload of the rocket engine is limited because of fact that one has to carry the oxidizer along with it apart from the fuel. So, therefore, that is the limitation, and we will be now looking at about a brief history of rocket propulsion or rocket engines. So, as the people are talking about that even 200 BC, that is before Common Era, the Chinese people discovered the black powder, and which is also known as the gunpowder, that is the propellant which made this rocket engine to propel or to design and develop, and that follows a discovery of fire arrow. Of course, if you look at in India, as per our mythology is concerned, it is the fire arrow was being used much beyond the 200 BC. However, there is no hard evidence, as some of the people just consider the mythology as a story book. And of course, there are several developments might have occurred. I am not going to detail about it, but one important thing what happens is around 67 CE, the hero of Alexandria, who invented a reaction machine known as aeropile, and it is a simple bladeless radial steam turbine, one can say that. Let me show you its pictures. If you look at, this is basically a aeropile engine which was invented by the hero of Alexandria, and this is your basically the fire, and which will be producing certain amount of heat, and this container is known as boiler, and which will be carrying the water, and this is producing the steam, and then the steam will be passing through this tube into this rotating device. This is rotating can say sphere, which will be into which the hot steam will be passing through, and it is having two jets. These are jets, two opposite direction jets. When this high temperature and steam will be getting into this here and it will be ejected through this jet, which is just opposite direction. As a result, this will be making it to move, because the when the steam will be going with a certain velocity, there will be some reaction over here and there is a reaction over here. This is the reactive force which will be acting. As a result, that makes it to rotate, and this is a radial steam turbine one can think of. So, that was the idea which was, although it is being developed, the people might not have formulated the third law of motion in 67 CE, but however they had designed and developed this device what as per the history is concerned, or it might be a sketch as such, and people might be really thinking is to be developed kind of things. So, later on, of course, people use some kind of a rocket engines in which there will be propellants, right, which will be burnt over here, and there is a small hole or the nozzle which will be allowing this gas to be passing through at a very high velocities, right. This will be quite a high velocities which will be, and that makes this rocket engine it to move. But however, they found that the motion is not very controlled. It will be moving in a very haphazard manner, such that you cannot really control it. And then later on, the people put a stick over here, a bamboo stick, and they found out that it is quite stable. It is going in certain particular direction. So, that really was a very important development that some of you might have experienced whenever we have a toy rockets during our Diwali festivals and other things. So, this was around in China it was being developed, but of course, some people claim that in India we are having these black powders and people are using these fire arrows earlier days. Around 900 to 1000 CE, the Feng Jishen fired a rocket using gunpowder and bamboo, similar to this what I have shown here. This is bamboo stick and the rocket engine, right. And using the gunpowder, the people are using the gunpowder here as a propellant. And of course, this was a very great development happened, so that people are having. And around 1232, one who developed a rocket sled, that means he made several kind of rocket together, and then tried to ignite it. And he was the picture what he says that it is he is the person who is sitting over in a chair and he was trying to make it to fly, and that is around 1232, but unfortunately this was a mishap and in which he died. So, later on there was a lot of developments, and then people like Genghis Khan and other warriors, they used the firepower to win a war against Japanese, and later on of course there was a lot of development occurs. In around 1275, Genghis Khan used these cannons made of gunpowders to win a war against Japanese. Of course, people use gunpowder plentifully, profusely in later wars, and we will see that in 1398 Sultan Mahmud used cannon attacks on the great warrior Timur or Tamerlane, known as Tamerlane. And also later on in 1633, Lagari Hassan Selvi took off with what was described to a cone shaped rocket and then glided with wings into a successful landing. That was a great thing happened, so that it will be properly done. And there is also a lot of innovation was going on in India, particularly is the Tipu Sultan and Hyder Ali, his father of Mysore, who were instrumental in developing the missiles for winning a war against the Britishers. This is occurred around something 1700 to 1760 kind of thing. Unfortunately, Tipu Sultan lost the war against the British people, but he had created a havoc. And with the fall of the Tipu Sultan, then of course the British really learned this thing, the process, and they took the charge of these missiles and they developed subsequently, which was used against the Napoleon, that we will see. And 1857, the Konstantin Edurovich Tsiolkovsky first talked about liquid fuel rocket engines. He was a Russian school teacher who wrote a paper known as The Exploration of Space with a Reactive Device, and he gave the concept of multistaging, and of course he used liquid oxygen and hydrogen as a concept. Later on it was used very much for developing the rocket engines, very powerful rocket engines. And 1914, the Robert Goddard used the D level nozzle for the first time on a rocket engine, doubling the thrust and enhanced the efficiency of the rocket engine by several times, and he was granted a patent on liquid rocket engine. And 1934, the von Braun scored his first successes with the design and development of V2 rocket engine, which was really created epoch, and which was powered by the ethanol and liquid oxygen. And this V2 rocket engine was really the starting point of the design of rocket engine, both by the Russian and the Americans, because after the fall of Germany during the Second World War, most of the scientists, including von Braun and others group, they went to America, and some of the groups went to the Russia. As a result, their space program really got boosted off. If you look at, as I told earlier, that 1923 to 1934, German demonstrated use of rockets to propel cars, sled and airplanes, and several of them. They were the really pioneer using the rocket technology. And 1944, the V2 rockets were launched against the London, and this rocket was the world's first long range combat ballistic missile and first human artifact to achieve suborbital space flights, and it was considered to be the progenitor of all modern rockets, as I told earlier. And 1949, Alexei Izev developed the first stage combustion engine, and of course around 1950 British used hydrogen peroxide and kerosene fuel liquid rocket engines. 1957, Russia placed the first artificial satellite around the earth. Of course, during this time there was a Cold War which is going on between Russia and the American, who were competing each other, particularly developing the missile systems and also the space technologies. And 1962, American used liquid hydrogen engine in the spacecraft, and subsequently in 1969 they could manage to land on the moon by Apollo 11 spacecraft, and that was really a great things for mankind to have a space programs. And later on, most of the developed countries and developing countries really steer their power and energy to have a space program. And so also the India, which is started this work in 1969 with the help of basically Sarabhai Professor Sarabhai, and also later on the other stalwarts joined, and of course some of you might be knowing their name, like Professor Satish Dhawan was also the key player in shaping the Indian Space Research Organization. Later on Dr. Abdul Kalam, who was third generation leaders on this field, and all of you might be knowing that he is a very great motivational speaker and person who has really motivated a lot of you and still is doing. So, if you look at we have developed several engines. To start with, Aryabhat, which is a satellite, was basically launched from the Russian launch pad in around 70s, and SLV is your satellite launch vehicle, which is designed and developed by India. You might be knowing the PSLV, that is Polar Satellite Launch Vehicle, which is the workhorse for our space program, and GSLV, Geo Satellite Launch Vehicle, which is nowadays being used very much for our most of the space programs. Let us look at little bit history about that, and if you as I told, Aryabhat basically launched from the Russian satellite launch pad, but later on we really did of our own, that is our launch pad was developed in Sriharikota, which is being used even today, and it was basically 10th August 1979, and satellite launch vehicle was launched from the Sriharikota, and this is the Rohini technology, and payload is around 35 kg. Unfortunately, it was a failure because of the valve which was supposed to work didn't work. It was a fault of the valve, and that was the major cause of vehicle to crash into the Bay of Bengal after just 317 seconds of its launch. And later on, of course, within a year, in 18 July 1990, satellite launch vehicle was launched from the Sriharikota, and that is Rohini RS-1, and again payload was 35 kg. It was a great success, and the people got enthusiasm, and then of course later on it was again a failure because it was placed into an unusable low orbit decay up, and it got decayed after 9 days. That was a failure. So, but again we are having launch vehicle in 17 April 1983. Again that is the payload is little bit increased, Rohini RSD2 41.5 kg. It was a success. Of course, there are several success and failure in the very beginning because of fact that people were trying to learn these technologies, but today we are at the better front, and nowadays people are using our vehicle for sending their satellite because of fact that it is very cheap, and also we could develop a certain technologies which are quite better than the others. As I told, like the satellite launch vehicle, augmented satellite launch vehicle, PSLV is polar satellite vehicle, and GSLV is your shown here, geosynchronous launch vehicle, geostationary satellite launch vehicles, and GSLV Mark III, which is having a very good capability of sending increasing the payload and also the range what it could achieve. So, let us look at certain technical specification of the GSLV, geosynchronous launch vehicle, and it is, as I told, as you can see from here, that is it is having the strap on motors, right. This is strap on rocket motors, and you are having various stages, like 3 stages in this case, and if you look at the length is strap on motors, this is the 19.7 7 meters and diameter is 2.1 meter, and gross mass is 4,56,000 kg. And in case of the stage 1, stage 2, stage 3, the 3 stages as I told earlier, that is the length is stage 1 is 20.3 meters and stage 2 11.6 meter and 8.7 meter stage. That you can see that length is decreasing as the in the upper stages, and diameter, of course, except strap-on motors, the others are remaining same, I mean that is 2.8 meters, and gross mass is also decreasing with the towards the upper stages, and propellant mass which is used basically nitrogen tetroxide, UDMH, unsymmetrical dimethyl hydrogens, and propellant mass in the strap-on motor, each one of them total is 4, is 40,000 kgs, and propellant mass is in the stage 1 1,29,000, and later on stages is much lower 37,500 kgs, and the stage 3 is 12,500 kg. And these are the various kinds of engines which is being used. If you look at the thrust is 290 kilonewtons, and in the first stage it is 4,800 kilonewtons, and the second stage is much lower 725 kilonewtons, and third stage is the 75. Why it is so, that we learn later on, that what is the advantages of using the stages, why you will use for strap-on motors. And the normal burn time is something 159 seconds, and then stage 1 is 93 seconds, but the burn time increases when you go for the second and start stages. Keep in mind that ISP is, of course, for the booster is 281 second, and stage 1 is 260 second, and stage 2 is 295 seconds, and stage 3 of course it is a much higher, that is 460 seconds, because it uses liquid oxygen and hydrogen as a propellants. So, with this we will stop over, and then we have seen that how India space program was developed, so also in around the world, and next lectures we will be discussing about applications what we can have. Thank you very much.